Alright, so this is LeetCode 704 binary search. So given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search basically for target in nums. If the target exists, then return the index of where target's found, and then otherwise, if it's not found, if target's not in the array, then we return -1. Okay, so and one caveat for this problem is that they want us to perform it in a big O of log n time complexity, runtime complexity. So yeah, so we're gonna have to do it using binary search. So basically, they want us to be using a time complexity that matches this one. So yeah, so if you're familiar with just searching in arrays, you could probably do this with a, let's see. You could probably do this in certain other ways with certain complexities, but they want us to use binary search, so it's a log n time. So basically, I'll explain a little bit as to why it's log n. There might be better explanations on YouTube, but I'll explain how I understand it. So let's look at the test case 1. So given this example nums and the target 9, we're going to return the output of 4. So we're going to return the output of 4 because this is index 0, this is index 2, or 1, 2, 3, 4, 5. Great. So we found 5 where there's 6 values, but labeled from index 0 to 5. Okay. So for binary search, what we're going to do is we're going to have a left and a right pointer. This is our left pointer, and it's going to be pointing at the index 0. And then we're going to have a right pointer, which is going to be pointed at the last index in the array. Great. And then what we're going to do is we're going to calculate a middle value. Because by calculating a middle value, you automatically can well, first you have to know that the input array is sorted, right? And if you know that the input array is sorted, then what you can do is calculate the middle value, and let's say that the middle value is 5 or 3, depends on it. This can get a little tricky if it's even or odd, but if you write your solution, it should account for that. But let's say that the middle value is this one right here, so this is our middle. Okay, our middle index is the value at the middle index 5. Is that greater than or less than our target value? So 5 compared to 9. Well, our target value is greater, and since our array is sorted, then we know that this whole side of the array can just get disregarded. We don't even have to deal with this anymore. We can just move this left pointer to here. And then we calculate it again, and then we get, we should find our middle value. Okay, so what this is doing is it's cutting the amount of time that we have to, the runtime in half each step. So the reason why this is O log n is because this is secretly base 2. And if you remember from math classes, let's say that, how do you solve a log equation? Well, this is our variable that we're solving for, and let's say that the size is, oh, actually, I'm not sure. We're going to test this out. So this is of size, what, 6? Right, so 2, no, okay, so I think this n is going to have to go here, so it makes more sense. So log of our n in this case is 6. which would give us 2 to what power is equal to 6, so it's about like 2 something, right? So let's choose choose a better number. So let's choose a number that's a power of 2. Let's do 2 to the third. So if it's 2 to the third, that would be 8. So let's say that we have an array of length 8 values. 8 values, shit's an 8. 8 values. Well, with a log n runtime complexity, it basically means that we're cutting the runtime in half by each step. So we're only going to do 3 actual computations before we finish our loop, basically. So that's kind of like my understanding of it. It might be a little flawed, but it's my understanding of as why it is log n. So that's that example. For this one, we just return -1 because our value isn't in the list. Okay, so let's go ahead and just leave this up here for reference, but we're gonna go ahead and start writing the code. So this is a time complexity of big O of log n, and then I believe the space should be big O of 1, but we can evaluate it again at the end. Okay, so what we're gonna do is we're gonna create a left and a right pointer, and the left value is gonna be equal to 0, and then the right value is gonna be equal to length of nums minus 1. And if this looks unfamiliar, basically this is a way of Python. You could this is a syntax in Python where you could initialize 2 values, 2 variables in one line. So left is going to initialize to 0, and right is going to initialize to the last index. Okay, and then what we're going to do is we're going to have a while loop. So while left is less than or equal to right, because in the instance where maybe we have an array that is of size, maybe say it's of 1 size, then our right and our left are going to be on the same size, and we still want to calculate this because this could just be our target value right here. So in the instance where left is less than or equal to right, and we're also doing that because we never want our left pointer to be to the right of the right pointer, if that makes sense. We never want these ones to kind of cross each other's paths. We only want them at most to be equal to each other. We only want them to at most be at the same index and never cross to the other side. Okay, so while left is less than or equal to right, what we're going to do is actually we're going to calculate our middle value. So middle is equal to left plus right, and we're going to do this in a parenthesis. What we're going to do is we're going to do some integer division, so the double dash divided by 2, that's going to give us our middle index. And what we're going to do is middle value is equal to nums of middle index. Great, so now we have a middle value. We can do our comparison. So if nums of, wait, no, we don't have to do that. We have our middle value. If middle value is, let's say, if in this instance, when our middle value was 5, if 5 is less than 9, our target value, less than 9 target value actually, then what we're going to do is we can just move our left pointer to the right of the current middle index. So we're going to say left is equal to middle plus 1. Great, okay. Else if, or elif, basically the way you can do it in Python is using elif, and then we're going to do the other situation where our middle value is greater than target. Great, so then what we're going to do is we're going to do the opposite. We're going to do right is equal to middle minus 1. Because that would be in the instance maybe perhaps let's just write a situation. So maybe we still have the same values, -1, 0, 3, 5, 9, 12. But our target value was 0. That instance would be our middle value, 5, was greater than our target value. So that would mean that we just move our right pointer over to the left of our middle value. Hopefully this makes sense. So what we're going to do is keep that. And then what we're going to do is else, this is the situation where our middle value is equal to target. So what we can do is just return middle index. Great. And then what I believe we can do is if we just exit this loop, then we just return -1. So let's evaluate the time and space. So yeah, so we're doing a binary search, so this would still be O of log n, and then the space we're not allocating any other space besides these constant variables. So these variables aren't going to grow in size as our input grows. So I believe it's still O of 1. It's going to run the code. Right, I did a typo, so this should be middle index. Let's see if this fixes it. Cool. So yeah, that is that's binary search. This is a really common problem, especially for internship interviews. So a lot of problems, a lot of medium or even hard problems build on top of this concept. So it's good to understand this and kind of be able to use it in other problems. So yeah, thank you for watching.